Hello everyone to our very first car video. In this video, we'll be discussing and going in depth about the anatomy of an internal combustion engine car. Specifically, we'll be looking at what front-wheel drive, rear-wheel drive, and all-wheel drive is, difference between turbocharged, supercharged, and naturally aspirated engines, what horsepower and torque are, and how does the car convert fuel to energy, launching a car, different transmissions and different types of gearboxes in cars, engine delay and kickdown, and how weight has a factor in making a car accelerate. So if you're looking to going into automotive engineering or anything car related, or just have a passion and interest in cars but don't know anything about them, well guess what? We got you covered, because this is Car Theory. Firstly, let's talk about the three main drivetrains. You may have heard of these terms before, but may not quite understand them. Front-wheel drive, rear-wheel drive, and all-wheel drive are known as drivetrains and tell people where the engine is delivering power to, either the front wheels, rear wheels, or all four wheels. Front-wheel drive is when the car's engine is placed at the front and only delivers power to the front wheels. The front wheels are responsible for speed and steering. It's said to be very common in many everyday cars, such as hatchbacks, sedans, SUVs, and minivans, because it reduces weight, decreases production costs, and improves fuel economy. Examples include the Honda Civic Type R, Nissan Sentra, Mercedes-Benz A-Class, Chevrolet Bolt EV, Hyundai Ioniq Hybrid, and many others. Front-wheel drive offers fairly good traction as well, at least better than rear-wheel drive, because the front wheels are pulling the car forward, and the engine and transmission is directly over the driven wheels. Rear-wheel drive cars can have their engines placed at the front, like the Mercedes-AMG GTC Roadster or the Dodge Challenger Demon, mid-mounted, like the Corvette Stingray or Lamborghini Huracan Evo rear-wheel drive, or at the back, like the Ferrari 458 Italia Spider. Rear-wheel drive is fairly common in many supercars. Rear-wheel drive cars have their engines which deliver power to the back wheels only. Rear-wheel drive has the back wheels responsible for speed and the front wheels for steering. This makes rear-wheel drive cars the best for drifting, although they don't have good traction, especially during the winter, because the rear wheels are pushing the car forward and the tires tend to spin a lot. All-wheel drive or four-wheel drive cars can have their engines at the front, like the Acura TLX or Lexus ES, mid-mounted, like the Audi R8 V10 Performance, or rear engine, like the Porsche 911 Turbo S. All-wheel drive has the engine delivering power to all four wheels. All-wheel drive has the rear wheels pushing the car forward and the front wheels pulling the car forward, all at the same time. This generates a lot of traction and has the best traction out of all the drivetrains. All-wheel drive cars are really good for climbing hills and going down hills. This makes it into a system that wants to continue moving forward. Turbocharged versus supercharged versus naturally aspirated engines. You also may have heard these names before, but may not give a single damn as to what they are. Turbocharged. Turbocharged cars have turbos. For example, the Honda Accord has a 1.5-liter single-turbo V4 engine. The McLaren 765 LT has a 4-liter twin-turbo V8 engine. Twin-turbo meaning two turbos strapped on the back. Also, when I say V4 or V8 or flat 6, it basically means the number of cylinders in the car. For example, when I say V12, it means 12-cylinder engine. Anyways, back to turbochargers. Turbos increase an internal combustion engine's efficiency and power output by forcing more air into the combustion chamber. This creates what many people call boost. In simple terms, a turbo is an air pump that enables more air to be pumped into the engine at higher pressure. Turbos usually offer up to 70 to 140 horsepower extra. Turbos are connected to the exhaust system and make use of the waste energy from the exhaust gases. The downside is that the turbos need to build boost first before it can be used, which is known as turbo lag. For example, the Porsche 911 Turbo S has a 3.8-liter twin-turbo flat-six engine, which has some turbo lag when putting your foot down on the accelerator. Supercharged. Superchargers are kind of similar to turbos because they increase the amount of air intake into the engine, creating boost. Superchargers can increase the engine's horsepower from about 40 to 100 at low engine RPM with low lag. However, since superchargers are connected directly to the engine, they have less efficiency because they use engine power to make engine power. For example, the Dodge Challenger Demon has a 6.2-liter supercharged V8 with rear-wheel drive, which picks up on speed relatively quicker and has very little lag at 80 kilometers an hour than the Porsche 911 Turbo S, which has a 3.8-liter twin-turbo flat-six engine, as mentioned previously. However, the Dodge may win over short distances, but the Porsche will eventually overtake it once the turbos kick in. Naturally aspirated. Naturally aspirated engines are much more superior at delivering consistent power levels throughout the engine's entire power band. Because there aren't any turbos or superchargers getting in the way of the engine or exhaust, naturally aspirated engines take off much better in terms of throttle response. An example of this is the Corvette Stingray, with its 6.2-liter naturally aspirated V8 with rear-wheel drive, or the Lamborghini Huracan, with its 5.2-liter naturally aspirated V10 with all-wheel drive. On top of that, they sound glorious. Horsepower versus torque. Horsepower and torque are the two main numbers that people consider in cars. Torque is known as the turning or twisting force applied by the crankshaft, and is the amount of work a car can accomplish and is measured in either pound-feet or Newton-meters. For this video, we'll be sticking to Newton-meters. Horsepower is how fast a car can perform or accomplish said work. For example, the Lamborghini Aventador SV Supercar has a 6.5-liter naturally aspirated V12 engine with all-wheel drive that puts out 750 horsepower and 690 Newton-meters of torque. This means that it's doing a small amount of work or applying a small amount of force at a fast rate. On the other hand, trucks, buses, and other huge vehicles usually have higher torque than horsepower because they need to be able to accomplish a lot of work but don't necessarily have to do it at a fast rate. For example, the Ford F-150 Limited truck has a 3.5-liter EcoBoost V6 with all-wheel drive that puts out 400 horsepower and 670 Newton-meters of torque. This means that it's doing a lot of work but at a relatively slow rate. How does the car convert fuel to energy? Internal combustion engine cars have over 2,000 different mechanical and electrical components, which have to accomplish certain tasks. The fuel tank stores the fuel and provides the fuel to the engine. The engine converts that fuel into power. That power is sent off to the transmission, which converts that power into usable energy in the form of gears, clutches, and other mechanical and electrical components. Then that energy is sent off to the drive shaft, which is connected to the axle. As the axle rotates, the wheels also rotate, making the car accelerate. All the waste produced at the end of the combustion reaction, such as carbon dioxide, carbon monoxide, and sometimes nitrogen dioxide, is exhausted out from the exhaust pipes at the back. During this whole process, however, the engine can lose up to 15% of its power due to mechanical inefficiency. There can also be a loss in energy due to friction of the different moving parts in the car. Launching a car. Cars are more likely to lose energy when drivers launch their cars too often. Launching a car basically means revving up the engine while sitting in neutral, then switching to drive so that the car can accelerate really fast. Most supercars actually have a special launch mode in them, such as the McLaren 720S and the Ferrari SF90 Stradale. Lamborghinis have something called thrust mode, which is considered a type of launch mode for the car. You basically put the car into Corsa, which is a special all-out sport mode for Lamborghinis, turn ESC off, which takes stability control off, and turn off traction control. Then you put your foot on the brake, floor the accelerator, and then let go of the brake after a second or two, so the car can launch and accelerate really fast. The same goes for the Audi R8 V10 Performance and Porsche 911 Turbo S. Stability control improves a vehicle's stability by not making the car slip too much and reduces the loss of traction on the wheels. Traction, by the way, is the grip of a tire on roads or wheel on rails. When people launch their cars, this causes a lot of harm to the bands and clutches of the car. So, in simple terms, don't launch your car unless you're in a NASCAR race or a drag race with a bunch of other supercars. Manual versus automatic versus automated manual versus continuously variable transmission. Every car out on the road has a different type of transmission and gearbox with a different number of gears. Manual transmission. In manual transmission, the driver selects all the gears manually, using the gear selector and the clutch. It's all based on the driver. The driver selects the best gear for the situation. Examples of this are the Audi R8 V8 and Ford Mustang, which both have a 6-speed manual gearbox. Automatic transmission. Automatic uses a torque converter, planetary gear set, and clutches or bands to shift through a vehicle's forward gears automatically. In simple terms, the car's engine decides what gear to be in. Some automatic transmission cars allow the driver a limited amount of manual control over the vehicle. This means that you can switch between the engine changing gears for you, or you can change gears yourself by using buttons, paddle shifters on the steering wheel, or the gear selector. Another name for this is the automatic and manual and shiftable automatic transmission. Examples of cars with a really good automatic transmission are the BMW 3 Series with an 8-speed automatic. Examples of cars with shiftable automatic is the Lexus IS 350 sedan, which has a 6-speed dual-clutch automatic and manual gearbox. Other examples include the Audi R8 V10 Performance and the McLaren 570S, which both have a 7-speed dual-clutch automatic and manual gearbox. Other cars, such as the Porsche 911 Turbo S and Corvette Stingray, both have an 8-speed dual-clutch automatic and manual gearbox. Some cars may have single-clutch transmissions, meaning the car only offers either the paddle shifters or buttons or gear selector, such as the Audi R8 GT Spider, which has a 6-speed single-clutch automatic and manual gearbox. Another example is the Lamborghini Aventador SVJ, which has a 7-speed single-clutch rubberized automatic and manual gearbox. Automated manual transmission. An automated manual is similar to manual because it has a mechanical clutch, but the clutch isn't controlled by the driver with a clutch pedal. It's actually automated using electronic, pneumatic, or hydraulic controls. It's referred to as direct shift gearbox, DSG, or a sequential manual gearbox, SMG. It allows for either fully automatic forward gear shifts or manual shifts through the gear selector or through buttons and paddle shifters on the steering wheel. Examples of this are the Mercedes-Benz CLK GTR, McLaren F1 GTR, and Porsche 911 GT1, which all have a 6-speed sequential manual transmission. Continuously variable transmission, CVT. Instead of having gear ratios, CVT has a drive ratio, which uses belts, pulleys, and sensors rather than gears to maintain a steady acceleration with no pauses for gear changes. Because of this, a CVT can keep the engine in its optimum power range, as a result, increasing efficiency and gas mileage. Examples of cars with CVT are the Honda Civic, Nissan Sentra, Audi A6, Hyundai Elantra, and many others. Engine delay and kickdown. Now, let's get out on the road and look at everyday driving. When you're driving on roads where there's 80 kilometers an hour as a speed limit, or 50 miles per hour, then you suddenly need to overtake someone, for example. You floor on the accelerator and you may notice some engine delay, and it may take a while for your car to start accelerating. This is because when you're cruising at 80 kilometers an hour, your car runs on a high gear. Let's put this into a real-world scenario. When you ride your bike and you just want to cruise, as in you don't want to speed up or slow down, do you put your bike on a high gear or low gear? I personally put it on a high gear, usually 5th. Then, when you suddenly want to speed up to climb a hill or something, do you leave your bike on a high gear or put it on a low gear? I usually put it on a low gear, either 2nd or 3rd. See, this is exactly what a car does. When you're cruising at 80 kilometers per hour, your car wants to run at the lowest possible RPM, or revolutions per minute, and use the least amount of fuel possible. And it does this by being in a high gear. Basically, your car's engine wants to find a sweet spot between how much work it has to do and how much fuel it can use. Basically, the ratio between the work being done and the fuel being used. When you put your car in cruise control on the 401 highway at 110 kilometers per hour, what RPM do you usually stay at? It stays around 2,000 for most cars, which is perfectly normal. However, there are some cars that stay relatively lower than that, and some cars that stay relatively higher than that. For example, the Corvette Stingray stays usually at 1500 RPM at the same speed, which is good and all for the engine because it doesn't have to do that much work to maintain 110 kilometers per hour, but the fuel economy isn't good. It can only do 3 miles per gallon, or 1.3 kilometers per liter, which translates to about 78 liters for every 100 kilometers. If your car uses a lot of fuel, the engine will most likely run at a much lower RPM, as mentioned by the Corvette Stingray. If your car uses very little fuel, the engine is probably working very hard, which will put it under a lot of stress. But when you're cruising at about 80 kilometers an hour, then you put your foot on the accelerator, the engine has to decide what gear is the best for the situation that you're in. So it downshifts to the gear that would be best for the situation that you are in. This is what many people call kickdown. Basically how long it takes for the engine to respond and downshift to the best gear needed for the situation and start accelerating. Let's look at some examples of some cars' kickdowns and what gear they shift down to. We're mainly going to be looking at supercars and maybe a few everyday cars. Let's assume that these drivers need to suddenly floor on the accelerator to overtake someone. BMWs such as the M5 and M8 competition have a good kickdown. At 80 kilometers per hour, they downshift to third gear pretty fast. The Corvette Stingray also has a pretty fast kickdown as well. At 100 kilometers an hour, the Corvette Stingray will kick down to third gear pretty fast. At 80 kilometers per hour, the Audi R8 V10 Performance usually kicks down to either second or third gear. At 80 kilometers per hour, the Porsche 911 Turbo S kicks down to second gear really fast. They all downshift to their own specific gears. It's usually the bigger supercars that have a kickdown problem. For example, the Ferrari 488 Pista, which kicks down to fourth gear at 80 kilometers per hour and struggles to pick up in speed. However, the McLaren 720S at 80 kilometers an hour also kicks down to fourth gear, but picks up on speed much faster than the Ferrari 488 Pista. Then the Lamborghini Aventador SV has a pretty good kickdown as well, similar to that of the Audi. It kicks down to either second or third gear. On top of that, it is naturally aspirated, meaning it doesn't have any turbo lag, just like the Audi, so it picks up on speed fairly well. Weight. Weight also has a factor in racing. Internal combustion engine cars need to have some weight on them so that the tires can grip the road, but too much weight will result in the tires having to carry so much load on them. On the other hand, too little weight will most likely result in the car not going anywhere and just getting a lot of the wheel spin. For example, the new 2021 Nissan GT-R Nismo has a 3.8-liter twin-turbo V6 engine that puts out 600 horsepower and 650 Nm of torque with all-wheel drive. However, it's fairly heavy. It weighs 1,753 kilograms, or 3,865 pounds, which is pretty heavy for a supercar. However, that weight kind of helps it launch really well, because that weight helps the car put the power down onto the road. This way it can get off the line with less wheel spin. But this doesn't mean that the heavier the car is, the better. And it also doesn't mean the lighter the car is, the better. If you have an ultralight car that puts out a lot of power, like horsepower and torque, the only thing you're probably going to get is wheel spin, because the wheels won't grip the road that well. Although, this doesn't mean that a light car is significantly bad. A lightweight supercar that puts out a decent amount of power is the Lamborghini Huracan Performante, which has a 5.2-liter naturally aspirated V10 that puts out 640 horsepower and 600 Nm of torque with all-wheel drive and weighs 1,382 kilos, or 3,046 pounds, which is fairly light for a supercar. The Lamborghini can get off the line really well due to its low weight and decent power output. However, a car that's pretty powerful but weighs a whole bunch is the Ferrari 812 Superfast, which has a 6.5-liter naturally aspirated V12, putting out 800 horsepower and 717 Nm of torque to the rear wheels only, so it's only rear-wheel drive, and weighs 1,744 kilograms, which may seem a little less than the Nissan GT-R, but it is actually considered a pretty heavy for a supercar. This makes it not get off the line as well as most other supercars. On top of that, since the engine is placed at the front, the rear wheels don't have good traction to grip the road. Another example is the Dodge Challenger Demon, which has a 6.2-liter supercharged V8 engine that puts out 808 horsepower and 972 Nm of torque, also with rear-wheel drive, but weighs 1,941 kilograms, 4,279 pounds, which is really heavy. On top of that, it has the same engine configuration as the Ferrari 812 Superfast. The engine is mounted at the front, making the rear wheels not have good traction, so weight definitely has a factor. Anyways, we hope you've all enjoyed our first video. If you found it enjoyable, helpful, and educational, be sure to hit that like button and hit that red subscribe button down below. Anyways, this will be it for our first car video. Hope you've all enjoyed, and stay tuned for the next one coming up on Car Theory.